Small, tiny, infinitesimal, nano. 10 atoms stacked on top of each other. That's the size of a nanometer. And within that minuscule space is where materials behave in unexpected ways, where you can guide electrons and photons down specific pathways. That's where the magic happens.
My group makes very extensive use of the Kavli Nanoscience Institute. This is a fantastic resource at the Caltech campus for nanoscience, fabrication, and characterization of structures. They close the entire loop from conception of a project to design. Usually design involves electromagnetic design, to fabrication in the K&I, and then we come back upstairs to the labs in Watson Lab, do optical characterization, and compare the results to our design. So it's an entire cycle.
The Kavli Nanoscience Institute has this particular synergy with the physics community, with the applied physics community, with the materials community, as it's uniquely positioned to not only fabricate devices for them, but to also characterize the performance of those devices, as well as to assess some of the features that we wouldn't be able to have access to without having the suite of the techniques that are offered by the clean room.
For my research, we really need to build this quantum device, which needs the feature size to be sub-micron level, and we need the precision to be less than 10 nanometers. So that's really when we need the equipment, for example, like the e-beam lithography tools, and we build whatever is in our mind, like microwave circuit or something else, into a real device that we can test and measure.
I have a project that is to make field emission diodes and triodes for high temperature environments. A very interesting example is space. Venus is a planet that has very high temperature in the surface. It's about 470 degrees Celsius on average. And therefore, if you want to take a mission lander there, you need to have electronics that can sustain high temperatures. Thanks to K&I, now I can make nanoscale features that before it was not something feasible to do with the technology we had in the past. And that allows me to have devices that can operate at voltages that are similar to CMOS technology.
So the Kavli Nanoscience Institute is the type of enterprise that spans beyond the clean room. One of the examples is this Surf the Wave program, where we bring in particularly brilliant undergraduates from places other than Caltech, such that they can get exposure on our campus, as well as to get familiar with our campus. And of course, we have a bit of an ulterior motive to inspire them to consider Caltech as for graduate schools. We also have the Distinguished Speakers Seminar Series. These speakers are very well respected by the community, and the types of boundaries that they push really inspire the students anywhere from undergraduate level to graduate students to postdocs and even faculty. Kavli really serves as the central point to facilitate such a lecture series.
The Kavli Nanoscience Institute at Caltech is more than a place. It's a resource and a launching pad for brilliant, out-of-the-box thinkers and scientists.